Welcome, Dr. Stephen Jonas. Thank you for joining me today on our CancerVax podcast.
Thanks, Ryan. Happy to be here with you.
What we usually do is I usually start by giving just a small introduction. And so I'll give a quick introduction on you, and then you can fill in the gaps and correct me if I've made any mistakes here. But
Okay.
Dr. Jonas is a UCLA physician scientist, which I think it's unique and really cool, by the way, Steve,
Uh-huh.
specializing in pediatric hematology and oncology. Um, Steve received his bachelor's degree in materials science and engineering and a master's degree in biomedical engineering before starting medical training to pursue an MD and a PhD, which you did at UCLA through I believe it's through the NIH supported medical scientist training program. Yeah. And so Dr. Jonas completed his pediatric residency and his fellowship training in pediatric hematology and oncology at UCLA at the Mattel Children's Hospital, where, if I understand it correctly, Steve, you were the very first trainee in a very specialized physician scientist track training, right? Established by the Department of Pediatrics at the UCLA David Geffen School of Medicine.
Yeah, I mean the leadership in pediatrics at UCLA really, saw a need for training the next generation of physician scientists and who wanted to focus on science, particularly, within the community of children's health.
Um,
And uh, they identifying that need kind of established a program. Pediatricians are all about milestones, right? So they developed a different tracks that you could focus on as a resident, and then potentially moving on into kind of the subspecialty fellowship kind of training. For me, it was hematology oncology. For others, it could be cardiology or whatever. And it just so happened that I was coming along when they were thinking about creating a track for a physician scientist to really kind of um, identify folks with that interest and kind of provide them with the mentorship and the resources that could help them kind of move along a trajectory to kind of become uh, uh, a principal investigator in these areas.
yeah, it's pretty cool just to be able to do that, and it's cool that those programs exist. But for you to be a pioneer in a program like that's quite remarkable.
Appreciate it. Yeah,
Yeah.
kind of
So,
started at UCLA life.
continuing your amazing bio, Steve. As I understand it, you now lead a multidisciplinary research team, right? That targets development and application of nanotechnologies and methods that support both childhood cancer and regenerative medicine. And also, you're committed to helping accelerate the discovery and implementation of innovative gene therapy and different approaches, right? And diagnostic strategies, et cetera. This is pretty cool stuff.
Yeah, I appreciate that. I think, in deep down, kind of owing to the engineering training, I suppose,
Yeah.
the idea is that engineers are tool makers and physicians are tool users. Kind of gone are the days of the barber surgeons. And so physicians have to interact with the folks who make the tools and the tools the engineers who make these and scientists who kind of interface with the physicians and the clinicians have to at some point speak a common language, and that's not always the case when you're talking about um, nanotechnologies or any of the areas that we kind of focus on. And so the beauty of my training at UCLA through my MD and my PhD is I got to I got to learn how to be scientifically multilingual and be the one of the people in the room who could kind of surf the interface of different disciplines. And I think that's where exciting questions come up.
Well, especially in the world of academia, those questions are important, right? Yeah.
Yeah, I mean, I think it's when we deep down, what we ultimately think about is, at least in our lab, or I kind of fancy our lab is sort of more the innate. There's a people who are the really going to be the scientific discoverers and the pioneers, and there are others that are kind of the scientific enablers. And I kind of think that our lab's kind of focused on being a little bit more of the latter.
Yeah.
Um, there are so many amazing colleagues on this campus and all over the world who are coming up with these amazing strategies and basically cargoes for creating new therapies. And our group thinks about, and hopefully our small contribution in this space is to think about how we can get those cargoes where they need to be.
Yeah.
Sort of like how Federal Express or Amazon sort of are part of our lives, have become integral part of our lives. They figured out how to put things in boxes better and get those boxes where they need to be.
Yeah.
There isn't necessarily a biomolecular equivalent for that, that is disease agnostic and is versatile enough to kind of address sort of the scope of applications. And so hopefully what we work on will help to address needs in different areas of science and help clinicians and scientists alike kind of probe different diseases or cancers or cells in new ways, and hopefully help them develop new understandings that can hopefully help propel the community forward.
Sure. Like crazy, crazy important stuff. So how did this whole start? This whole thing start for you? Tell me, where'd you come from? What's your background, and how did you end up getting involved in medicine and also in research
Yeah,
and
well,
oncology?
in oncology in particular.
Sure. Yeah.
Yeah, well, I mean, I'll give you the shorter version, I suppose, but now that I kind of look back at everything, but no, I guess I'm a Midwestern kid at heart. I grew up in the Detroit area.
Hmm.
Um, my parents were in the automotive industry,
Hmm.
and sort of being around that sort of culture and kind of engineering background,
Hmm.
kind of going through high school and graduating from high school and figuring out where I wanted to go. I ended up going to the University of Michigan, as you said in your intro. Um, Before that, in high school, I think where the medicine bug sort of gestated a little bit
Yeah.
was I had the opportunity to be nominated by a teacher in high school, who was pretty pivotal for to kind of my development, who nominated me for something called the National Leadership Forum on Medicine,
Hmm.
which I guess is essentially like a pre-med summer camp for high school students.
Wow.
And so there are different sites across the country, and I got placed in one in San Francisco.
Hmm.
And so it was a 2-week kind of immersion of like what medicine could be for someone with a high school mindset, I suppose.
Yeah.
And, from that experience, I really sort of keyed in on, that might be an interesting career path if I'm lucky enough to kind of
Yeah.
follow kind of uh,
That
the
trajectory. Yeah.
that trajectory, and the Joseph Campbell kind of path, I
Sure.
suppose.
Sure. Yeah.
And or at least that's what the medical school essays I'll say. But going and moving on to college, it's the analogy I used to use was like, we have like there's this book Into Thin Air, right? And so it's about
Oh,
climbing
sure. I know that book.
at that summer camp thing. One of the keynote speakers was basically dean of medical school admissions, and he used that book as an example, as
Hmm.
saying, medicines is a great career, but to get to be part of this community, what you don't just necessarily jump in to be a doctor. You don't necessarily jump into climbing Mount Everest, just like these guys did, right?
Yeah.
When you're when you're trying to summit Everest, you have to get to base camp first.
Yeah.
And so the journey to base camp is just as important as the journey to the summit. Um, and that's what he sort of encouraged everyone to kind of think about in terms of getting to um, finding yourself in a career in medicine, was to kind of take advantage of the opportunities that were out there, and kind of see how that kind of colors how the type of physician that you're going to be in the future. And, you could be volunteering at certain things, or, you could be crazy athlete, you could be, working in research labs, or whatever, but all of those things are sort of touchstone moments that are going to inform what you how you kind of approach the summit when you get there. And so
What a great analogy I think that is.
it's
And
kind of cool, right?
yeah, no, I think, and it's so applicable too, especially as a young person wanting to, considering medical school.
Yeah.
So maybe as a follow-up to that, Steve,
Yeah.
what was your summit? Or what was your base camp actually? I know what the summit looks like because you're there,
Yeah.
but what was your base camp?
Yes, I mean, I guess, in that analogy, or as the personal statements went, the base camp was really finishing undergrad, and,
Yeah,
and finishing my engineering journey at Michigan,
yeah,
where, I had, the opportunity Michigan was an amazing place to kind of start this journey.
yeah.
I ended up, the cool thing about Michigan is that, they had, there's no shortage of amazing mentors that were out there.
That,
And, from day one, they place you with a mentor. And so one of my mentors was, actually a professor in material science and engineering. I had no idea what material science and engineering was at the time. I was like, oh, bioengineering.
yeah,
But Michigan actually didn't have an undergraduate biomedical engineering at the time, because it was, I'm dating myself, I'm old, I guess. But the way you sort of had to do bioengineering back then in Ann Arbor was, you had to specialize in one of the more, shall we say, traditional engineerings.
correct.
And
Yeah,
then uh, there was a program where basically you got your bachelor's, and then you get your master's to
mm,
subspecialize in the bio-related form of that, right?
sure, sure.
And I think as biomedical engineering matured, they eventually made an undergraduate department, but that's sort of
Again,
the logic.
another pioneering moment for you, Steve.
I guess, right. I wasn't part of that crew, but it's story of my UCLA life, at least.
Yeah.
Um, but the one of the people, the faculty members I was kind of matched with as a mentor, she was a material scientist, and so we talked about interest in medicine, and how that might relate to engineering. And I thought engineering would be a cool thing to major in, because I enjoyed science and math. As I was kind of growing up, and in case medicine didn't work out, because there's no guarantee you're going to get in these days, or back then, or these days now, it would be really cool. Thought it'd be really cool to have a job as an engineer.
Yeah.
Um,
Great thought.
and
Yeah.
and yeah, so she said, she always, when we sat down, she said, well, if you're thinking about engineering and medicine, you should think about majoring in material science, because material science is the science of stuff.
Yeah.
Everything in the universe is made out of stuff, from the computers that we're on, kind of being made of stuff that helps the ones and zeros of the
Code.
and electrons kind of, and the code kind of function, to um the 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 batteries in your cars and your iPhones and all the other stuff, but your body is just made of smarter stuff to a certain extent, right? So your bones are basically ceramic composites of different materials, and the proteins and nucleic acids that kind of are the building blocks of your cells, are basically different polymers of different amino
Totally.
acids in case of proteins and whatever, right?
Yeah.
And so if you think about things at that scale, ultimately material science is a way to think about it at that length scale, but also see how changes or tweaks at that scale can affect the macro scale.
Yeah. Yeah.
And having that lens really kind of informed kind of what we kind of I kind of moved on to. So I had opportunities at Michigan to start from kind of, first semester on in a research lab with, some great folks in the in a who ran the molecular imaging group at Michigan at the time, Professor Ross and Professor Chenevert, and then sort of spent a couple summers doing kind of industry internships at Corning, and I did a year off at co-op with Johnson and Johnson's orthopedic group, which is called DePuy.
Was that
Yeah.
DePuy Synthes, I think, right?
Did they merge? It was just DePuy back then.
Just, yeah. I think J&J bought DePuy, and then they bought another one. DePuy. I think it's now DePuy Synthes, but was that
Yeah,
in Chicago? Is that where that was?
close. It was in Fort Wayne, close to Fort Wayne. It was actually between Chicago and Fort Wayne. There's a town called Warsaw,
Yeah.
which they dubbed the orthopedic capital of the world because I guess DePuy was there, and I think Stryker was there and stuff like that.
Yeah.
And so I got to be part of an engineering team that was working on different hip and knee implants and stuff like that. And really got a chance to see how kind of the engineers and the marketing people and or not marketing, but more like product development people,
Yeah, sure.
and physicians actually kind of interacted to develop different types of medical devices. And at Corning, those experiences were a little bit more kind of basic science oriented. The first summer was basically working with their kind of photonics business on a team on a particular kind of manufacturing process that they had at the time for particular photonic component. And I told my boss at the time, hey, I'm kind of interested in medicine, and I know Corning does a lot of life science stuff because all our labs are sort of covered with Corning Corning products. And if I'm lucky enough to be invited back, is there a chance to kind of switch into that?
Yeah.
And that really kind of placed me. So the next year, I went and was part of more their science and technology group as opposed to a product development group, and kind of got matched with a surface chemistry team. And that really kind of propelled my interest in the science part of that stuff. I think my first real big papers and awards and patents were from those experiences. And in part of those experiences, I learned that there are people who do MD PhDs. And one of the grad students I was working with was in the Michigan MD PhD program, and got to see the scope of that training. That there's possibility to kind of merge those areas together. And what the marriage of those two kind of feel that aspects of training could open for you kind of moving down the road. So
yeah, it really is a remarkable. And as you know, in our industry, we work with a lot of IP lawyers, and very similarly, you're at law school, but prior to law school, you're master's in chemistry or a PhD in chemistry or a PhD in biology or PhD in something, and then law school, right? But just listening, Steve, it's almost as if you're an engineer / industrial designer / doctor / brilliant researcher, but being able to have sort of, like you were saying, that vantage from each of those different skill sets, it really does set you apart as someone who's very, very unique in their field. I applaud you.
I appreciate that. Yeah, I mean, there's I think especially in pediatrics, right? Pediatrics is an awesome area of medicine, and I think a lot of folks get into pediatrics to for obviously the reason to take care of children, but they're not necessarily getting into a more pediatric focused career that combines the sciences.
And
Um,
it's interesting is as a father of 8 children, um, I'm obviously deeply concerned with pediatrics, and as you take a look at cancer now as the second largest killer of people globally, you marry those two things together, and that's I have a lot of, just on a personal level, a lot of passion for for looking for ways to help children and to try to eradicate cancer. And as you know firsthand, one of the things that we're doing at Cancer Vax is working on this Ewing sarcoma project, which
mhm.
we dub as children's cancer. And then obviously we have the universal cancer vaccine that we're working on as well. But I'd love to just hear a little bit, and I know that as a PhD, you're in the lab and
Mhm.
you have people in your lab, but as an MD, you're in the clinic as well.
Mhm.
And so I'd love to just kind of understand a little bit about that balance and what it means to you, and what excites you about some of these programs that we're working on.
Yeah, I mean, I kind of gave you the early part of for that early part of that answer. Uh, the later part is I ultimately, left for graduated and went to medical school through the MD PhD program at UCLA and sort of developed along this path towards childhood cancer as a kind of a calling from a physician scientist standpoint. Um, we can go into the reasons for that at another time. But to kind of more directly answer your question, yeah, I mean, I totally agree with what you say, what you said earlier. The thing about that I think a lot of people don't realize is that a lot of pediatric focused diseases are considered rare diseases, so they don't get kind of the attention or the focus of people in the pharmaceutical industry um, that's more
Orphan status.
lifestyle choices or different issues that adults face might they're not considered money generators,
That's right.
and that's the unfortunate part about all of this, and I think some of the funding from a scientific standpoint also kind of speaks to that. The NIH is comprised of different institutes, the National Cancer Institute being one of them, and out of and the National Cancer Institute is actually the biggest of the NIH institutes in terms of funding and in terms of scope, scientifically. And only about 4% of their budget actually goes to childhood cancer research.
Amazing.
So you're thinking about this big pot of money, you only get 4% of that. And that's where, the people focusing on childhood cancer research have to play.
That 4% is spread over a lot of different types of children, childhood cancer as well. So
Exactly,
that's not a very big
exactly.
pool.
And
Yeah.
across, investigators, all over the country. And so, the pediatric cancer community has had to really galvanize in ways to kind of have more grassroots efforts that help seed ideas uh, to really bring them to the forefront so that you can get on the NIH's radar or even past that towards developing sort of the some of the advances that we see. And that's where kind of engagement with academia and industry has really blossomed into some really cool potential collaborations like what we have at UCLA and Cancer Vax, in terms of the projects that you kind of outlined. you know uh, you mentioned the Ewing sarcoma project, and Ewing sarcoma is the second most common um, bone and soft tissue cancer that's out there. And the sad reality is that the first line treatment, chemotherapy for that particular disease, hasn't really changed since uh, the basically the early 80s. I could be I think I'm being conservative with that. And you know, while we've been able to really, to an extent, optimize the delivery of those agents, we
Yeah.
don't necessarily have something that's more targeted, or that can really fight the cancer when it's spread. So if you have evidence of metastatic disease or progression while receiving chemotherapy, your survival rate drops in half.
Yeah. Yeah.
And
That's
that's a
not
tough.
uncommon.
That's not uncommon,
Yeah.
for sure, especially in the sarcoma space and for children and adolescents and young adults. Um, but it's a it's something that we need to think about and think about how to address. I mean, I'm fortunate also as a pediatric oncologist that, because of the community that we have, and how it's been research focused, overall cancer survival rates across all pediatric cancers are actually about 85%, which is amazing. It's a testament to that
That works.
engagement and
Mhm.
that collegiality.
Yeah.
Um, that also means that 15% of our kids don't get our best shot up front. And that's a gap that, I think we can close with some of the partnerships that we can kind of bring to the table.
I think, Stephen, that's one of the things that obviously our mission at Cancer Vax is to try to bridge that gap a little bit more, and we get so excited and feel very honored and grateful to work with UCLA and folks, individuals such as yourself, who have not just committed the energy into learning and understanding this trade, but have really dedicated a big part of your life to seeing it and trying to fix this. So it's pretty neat. We feel very grateful to be working with you.
I appreciate it. No, I mean, it's really humbling to be part of a great group of folks that we've assembled, both at UCLA and working with you, Ryan, and the team. It's been great to see how we're progressing through our milestones to get to where we all want to be.
Yeah, it's exciting. So, lastly, one quick final question, Steve.
Mhm.
A young girl, a young boy coming up through somewhere in the Midwest. You and we've already
Yeah,
talked about our how we share Michigan roots, but
yeah.
who has an interest in either the research side, as a PhD, or the medical side as an MD. What advice do you give them?
I'd say you got to think about, keep on being curious.
Yeah,
A lot of medicine is protocolized. You're following a path.
yeah,
The cool thing about being a physician scientist, is, especially in pediatrics, is that I get to feed my internal Peter Pan syndrome. I get to be creative. I get to think about what a my own protocol might be, and I get to approach things from different vantage points. Particularly when we think about some of the nanoscience approaches that we take to helping to contribute on different scientific projects, and kind of the different questions that we pose in our work in the lab. We think about, from a nanoscience perspective, you know, shrinking tools down to kind of the scale of the inner workings of a cell,
it's
and
amazing. Yeah,
thinking about how we can create tools that can, help you generate a capability or data that can kind of feed into this new, it's not really new, but this kind of more global concept that's kind of emerging of precision medicine. How can we, or precision oncology in this case, how can we tailor medications to a particular patient, an individual patient's cancer or disease? That's going to require new types of tools, new types of understanding. And in terms of having tools that can generate the massive amounts of data that can kind of feed that engine, and then ways to interpret that data, and ways to implement, what you actually
Come up with.
accomplish. And so there's so much out there that someone interested in this space can really kind of latch on to. And it's really just kind of, I guess my advice would be to keep an open mind to how areas areas can connect. There's a certain ways where certain times in our lives where we get kind of set in our ways. But if you're a lifelong learner and you're able to really, get to a point where you can see beyond kind of the forest a little bit, there are cool connections that are out there. There's a symbiotic part that
I love that
hopefully you can tap into.
Yeah, I think that advice of being curious is remarkable. It really is, and that's what it takes. Sometimes it takes bucking the system a little bit. I think curiosity can come in a lot of different variations. How you look at a problem, how you solve a problem.
Yeah.
And so I think that's really great advice.
Yeah, and I think and it's not just the kids in the Midwest, right? I mean, I think what we have to do and our responsibility, from a scientific standpoint, is to kind of bring more people into this space and have them be more literate in how we approach scientific questions, and figure out ways to democratize some of these therapies. The therapies that we're talking about right now, that are either in development or currently being tested or recently approved in terms of cell-based therapies in such as a CAR T cell, they're really expensive. It's like $500,000 a dose, right? And there needs to be ways to, or we have to, I think it's our responsibility to think about ways to or democratize these things and increase access to tools to deploy these therapies, or
Yeah.
to allow researchers to work on new therapies.
Sure, and I would say democratize it from start to finish. It's not just the end product and the cost. It's
it's the
right?
upfront research to it too. Like the tools
100%.
that people need to develop the next generation of this stuff are crazy expensive. So if we can kind of use creative ways to bring someone from, I don't know, a medically underserved area or country into this space, they might be, the next brilliant researcher out there.
Sure. I love that. Great advice. Steve, thank you. Thank you very much for your time today. It's always fun talking to you. I love
Anytime,
what
right?
you're doing, and you are one of those people who, and you're humble, so you might blush a little bit when I say this, but you're one of those rare people that are behind the scenes doing so much good, and the world needs more Steve Jonases around. But so thank you.
Appreciate it. Well, thanks for having me, Ryan. Hopefully, we can do it again sometime.
Let's definitely do it again sometime.